Hey everyone, welcome to Tutoring. I hope you're having a great day. Today we are doing Chapter 6F, Question 1. So this is your related rates topic for differentiation. And Question 1, it is pretty easy for Part A at least, if you know the topic. But Part B is what I want to go through, okay? So let's get into the question. Hopefully this video helps you solve your problems in this chapter. Let's go. Question 1. The radius of a spherical balloon is 2.5 meters and its volume is increasing at a rate of 0.1 meters cubed per minute. Well, first things first, this is one huge balloon. It is 2.5 meters in radius. So that's in meters. So 2.5 meters in radius. Probably, I have no idea what kind of balloon this is, but it's a big one. And it's increasing. So this balloon isn't just big, but it's also increasing at a rate of, so the VDT, because the volume is increasing, at a rate of 0.1 meters cubed per minute or 1 over 10 meters cubed per minute. Whenever you're doing related rates question, make sure the units are all the same. So if this radius is in meters, check that your volume is also in meters cubed. Or if your radius is in centimeters, check that your volume is in centimeters cubed. If it's not, then you have to do some conversion, okay? So just be careful with that. Right, let's go through part A. At what rate is the radius increasing? What does that mean? Well, they want you to find the RDT, the change of radius in terms of time. How do you do that? Well, in related rates, guys, you have to use the chain rule, essentially the chain rule formula to help you solve for this. So the RDT, we know the VDT right here, it's increasing, positive 1 on 10. And if you want to find the RDT, well, we need to get rid of the dV. If you want to do that, you put the dV at the denominator so it cancels out. And then at the top, we want the R, right? So change in radius. So the R over dV. Well, how would you find the R dV? As we know, the volume of a sphere is 4 over 3 pi r cubed. So if you want to find the R dV, we find the V dr first and then flip it over, right? So the V dr, in this case, we bring the 3 down and you just end up with 4 pi r squared, okay? So we're just deriving in terms of R. And then afterwards, we flip it, the R dV, and that is 1 over 4 pi r squared. And then you chuck everything into this equation. So the R dt is equals to the V dt, which is 1 on 10, right here, the V dt, times by the R dV. The R dV is 1 over 4 pi r squared. And then multiply them together, guys, and you get 1 over 40 pi r squared. Now the goal is at what we need to find the rate that the radius is increasing when the radius is 2.5 meters. So what you do is you sub in R equals to 2.5 meters. So we sub that in, guys, and you will end up with, so 5 on 2 square that, 25 on 4, 10, 25, so that is, I'll just do it quickly, you can do this on your own time, but it's 1 over 250 pi, okay? So that is to solve part A. Right, now on to part B. Also, if you're answering related rates, don't do what I just did there. Make sure you answer the question fully, okay? So at what rate is the radius increasing? Say the rate of the radius is increasing, so just write it down. Rate is increasing at 1 over 250 pi meters, not meters, meter per minute. And that's it, because it's talking about the radius. Right, and then part B, it's asking at what rate is the surface area increasing? So what are they asking for? They are asking for the A dt, okay? So at what rate is the surface area increasing? Well, if you want to find the A dt, so this is the good question, question B, you have once again, related rates, do the same thing. Find two derivatives that will multiply to give you the A dt, because you can't, just get the A dt out of nowhere, okay? So how can you get the A dt? We need the A first. And the first thing that comes to mind is, obviously we need the A. And then what is dA over? Well, you can have it as dA over dr. The reason why we did that is because there's actually an area formula for, surface area formula for a sphere, which is 4 pi r squared. And here's a quick tip, guys. The derivative of the volume in terms of the radius is equals to the surface area of the sphere, okay? And then, of course, we derive that the A dr is equals to 8 pi r, okay? The A dr, we multiply that by, we need to get rid of the r, so the r has to be on top, and what's at the bottom? Well, we need dt, right? So it's the r dt. Have we found the r dt before? Yes, we have, which is in part A, right here, the r dt. So all we have to do is just plug in the numbers. The A dr is 8 pi r, and the r dt is 1 over 250 pi, because it's essentially at the same radius, right? So you can just chuck it in. It's 1 over 250 pi. And then sum in r equals 5 on 2. In this case, I'll simplify everything first. So get rid of the pi. Right, and then we simplify this. And then we're left with 8r over 250. Then we sub in r equals to 5 on 2 once again, because that's the 2.5 meters that we need. And we will end up with, so 8 multiplied by 5 on 2, that is 20 over 250, which is 2 on 25, okay? So 2 on 25, make sure you always put your units. Surface area increasing at a rate of 2 over 25 meters square per minute, right? Because the surface area is meters square, volume is meters cube, and rate is just meters, okay? So that's how you solve part B, guys. It's essentially just inventing or trying to think of two derivatives that multiply each other to give you what you need to solve the question. Right, and that is it for question 1 for chapter 6F. I hope you found this video useful, guys. And aside from that, thanks for watching. I'll see you in the next video.